When a critical production app suddenly drops its database connection, panicking and trying random fixes is a recipe for disaster. Experienced engineers immediately map the failure against the 7 layers of the OSI model. The Open Systems Interconnection model tracks data from raw physical pulses up to the application code itself. By treating it as a step-by-step diagnostic checklist, you can confidently rule out massive portions of the infrastructure and locate the exact point of failure. A bottom-up approach starts at layer 1, the physical layer, and layer 2, the data link layer. In a traditional data center, this means checking physical Ethernet cables, switches, and network interface cards. In a modern cloud environment like AWS or GCP, this translates to verifying that your virtual machine instance is actually up running and has a valid, operational virtual network interface attached to it. If the hardware layers pass, you move up to layer 3, the network layer, which handles logical IP routing. This is where you test if packets can physically cross the network to reach the destination using commands like ping to check basic reachability, or traceroute to inspect every single router hop along the path. If ping fails, the issue is likely a broken network path, a misconfigured cloud route table, or a stateless network ACL blocking traffic at the boundary. However, if ping succeeds, you immediately ascend to layer 4, the transport layer, which manages host-to-host communication using TCP and UDP protocols. Here, use utilities like netcat curl, or telnet to check if the specific port, such as port 3306 for MySQL or 4043 for HTTPS, is open and actively listening. If a ping works, but the port connection hangs, you have successfully isolated a layer 4 issue, usually caused by a stateful security group firewall or a database service that completely crashed. If the network, routing, and port connections are completely solid, you can completely skip over layer 5 and layer 6, the session and presentation layers, and straight to layer 7, the application layer. This is the top of the stack where human-facing software protocols like HTTP, DNS, and TLS operate. At this stage, your troubleshooting tool shifts to analyzing raw application behavior, server logs, and HTTP status codes. If code reveals that your network packets are arriving safely, but the server is returning a 502 bad gateway, or a 500 internal server error, the underlying network, routing, and firewalls are 100% healthy. The issue lies entirely within your application runtime, an invalid database credential string, or an Nginx proxy configuration error. Methodically climbing from layer 1 up to layer 7 completely eliminates guesswork, allowing you to debug complex microservice architectures in seconds.